gland, the pancreas, the ovaries, and the testes. However, I received an email from a student from SMAC who was asking about the pineal gland, because he was saying the last time I talked about pineal gland, I didn't talk about it. So I will start with the pineal gland. As you see, the pineal gland is also located just at the base of your brain in the head region. Just its role basically, it plays a major role in secreting a hormone we call melatonin. This hormone, melatonin, this hormone is responsible for regulating your sleeping patterns, both for the circadian rhythm and then the people who sleep at night. So who have the reverse rhythm of sleeping. So melatonin hormone is the major hormone secreted by the pineal gland, and its major role is to regulate your sleeping pattern. And then the other gland that I've not highlighted most is the thymus gland. As you're seeing on the on your screens, the thymus gland is located just in between you on your breastbone, just behind your breastbone, or what you call the sternum. So it is in your chest region. What is its role? This gland plays a major role in the immune system, but also it has some part it plays in the endocrine system. In the immune system, this gland is very well developed in babies or infants. It's larger in young babies, but as we grow up to teenage years, the moment we reach adolescence and we start exceeding to adulthood, this gland starts decaying, or it starts reducing, disintegrating, meaning that its major role is done during infancy. And what is its major role? Its major role is boosting and providing a strong immune system to the young ones. We all know that when we are still young, our body's immune system is not very well developed. And so this thymus gland plays a role in producing what we call the progenitor cells, from where the lymphocytes or T lymphocytes, part of what you call the white blood cells at your age or at your level, let us say white blood cells. These lymphocytes are which are produced by this thymus gland, are very vital in giving the young ones a stronger immunity against disease-causing pathogens. But not only does it play a vital role in strengthening the immune system or providing or boosting the immune system of the infants, it also has a major role in guarding us against cancerous cells, as it destroys all cancerous cells in our body, this thymus gland. So it's a very, very vital gland in our body. So far we have looked at the pituitary gland, the pineal gland, the parathyroid, the thyroid, and then the thymus gland. For today's lesson, I promised that we are going to start from the pancreas. As you look, it's just within the abdominal region where we have our kidneys. It's an accessory region for our digestive system within our abdominal region, just in between the stomach and the duodenum. The pancreas is both an exocrine and an endocrine system. Exocrine in such a way that it has a duct where it releases its contents via the pancreatic duct. In that sense, it is helping, its major role is in the digestive system, where it secretes pancreatic juice containing a lot of digestive enzymes such as pancreatic amylase, the lipase, and also the trypsinogen enzyme that is used during digestion. And in that sense, it is exocrine gland. But here, in this context, we are going to look at it as an endocrine gland when it is ductless. So in this sense, when it is ductless, the pancreas secretes two kinds of hormones. And these hormones are secreted from the islets of Langerhans, the alpha and beta cells of the islets of Langerhans. And these hormones are insulin, and glucagon. These two hormones are secreted from the islets of Langerhans within the pancreas, particularly within the inner medulla within the pancreas, the islets of Langerhans, the alpha and the beta cells. And these two major hormones control the amount of sugars in your blood, or they regulate the blood sugar levels in our blood. How do they do it? Their secretion is stimulated by the changes of blood sugar levels in our blood. Take for instance, immediately after a starchy meal or after a meal, our blood sugar levels rise. Why? After a starchy meal, starch is being broken down to maltose, which later on is broken down into glucose. And thus, that glucose is absorbed from the digestive tract into the blood system or the bloodstream. So there will be a lot of glucose in our blood, and so there will be a high blood level. But remember, blood glucose level. But remember, the amount of glucose in our blood is always at a particular set value, what you call the norm or the set point of around 90 milligrams per 100 milliliters of blood. So if we eat a starchy meal and the blood glucose level exceeds the 90 set point, then we are bound to undergo serious changes to the extent of us trying to urinate or to produce urine that contains sugar, or to the extent of us getting diabetic in nature. And so because of that, the pancreas, when it is very functional, it sells the islets of Langerhans. In any case, there's a high rise in blood sugar levels. They will release a hormone we call insulin. Insulin secreted from the islets of Langerhans of the pancreas directly into the blood, because at that point the pancreas is ductless, and then transported from the blood, through the blood towards the liver. And there, the insulin will stimulate the conversion of the excess glucose into glycogen for storage in the livers and the muscles. So the words being used here are stimulates. Hormones stimulate conversion. Hormones do not convert. Just like enzymes catalyze, you have to follow the word enzyme with catalysis. The hormone, any hormone, whatever work the hormone does, you have to pair it up with the word stimulate. So this insulin hormone stimulates the conversion of glucose, which is in excess anyway, to glycogen. And this glycogen is later on stored within our liver and the muscles. And as such, the amount of glucose that is in our blood reduces back to the norm. But then in any case, the blood sugar level goes very, very low. Like if we fast, if you take long without eating, or if you starve for some good times without having food, then a hormone called glucagon will still be secreted from the islets of Langerhans of the pancreas. And then this glucagon will be disseminated directly into the blood to the liver. And when it reaches the liver, this glucagon hormone will do the opposite. Because there's no enough sugar levels or sugar in your blood, this glucagon hormone, it will stimulate the conversion of glycogen back to glucose, such that the stored glycogen, like you stored it, it was a reserve, the stored glycogen in your liver and the muscles will be reconverted back to glucose in order to raise your blood glucose level, to give you some energy. So this is the role of the pancreas as an endocrine gland. Its role as an endocrine gland rotates around regulating the amount of sugars within your blood. And basically we look at it secreting two basic hormones, insulin hormone and glucagon hormone, whose secretion is always stimulated due to changes in the blood glucose levels. Now, what would happen to your body if you had a defected pancreas and your islets of Langerhans cannot secrete enough of the insulin or enough of the glucagon? Then we are going to experience imbalances in the blood sugar levels. Take for instance, every time we eat a meal or a starchy meal, our blood glucose levels would rise beyond the norm, and they will not get back to the norm because we cannot secrete enough insulin. So at that point, we become diabetic, or we get a condition or a disease, a chronic infection or disease we call diabetes mellitus, obulwadde bwa sukaali. So what that means that your pancreas is defected and it cannot produce enough insulin. In any case, every time you eat a starchy meal, then the glucose levels will be rising and rising, but there's no insulin to convert the excess glucose back to glycogen for storage. And so your blood sugar levels always remain high. And that is why they say, this person aina sukari oba yalwala obulwadde bwa sukari, or that person has high blood sugar levels. So that is diabetes. But then that is a short term. In the long term, is if the blood sugar levels, still this is a short term, the other short term effect of the blood sugar rise, if the blood sugar levels rise to the maximum and they are not controlled back to the norm, you can end up going to coma because of very high blood sugar levels. But then in the long term, if the sugar levels remain high and you are not getting insulin tablets or injections to reduce the blood sugar levels back to the norm, then you undergo muscle wasting and you lose a lot of weight. In most cases, you've seen some of the diabetic patients who have reached a particular level, they keep on reducing weight. And that is another long-term effect of having high blood sugar levels in your body. And so, in most cases, people who are diabetic, their pancreas are defected, and because they cannot produce insulin, enough insulin naturally in their bodies, when they go to the hospitals, they give them artificial insulin. So in the hospitals, they can make insulin. And then this artificial insulin is either in form of injections or tablets. But majority of the patients prefer the injections to the tablets, and which is a common UNEP question, that why is it that most diabetic patients take insulin in form of injections and not tablets? You realize that an injection is intravenous, that insulin hormone is introduced directly into your bloodstream, and thus it will directly stimulate the conversion of glucose back to glycogen into the bloodstream. But when you take a tablet via your GIT, or what you call the alimentary canal, it has to be digested normally. And then insulin is a protein. It's a hormone. It's a protein in nature, and then it will be broken down to amino acids. So the rate of absorption of the hormone is very low, first of all. And lastly, the hormone is protein. It will be broken down just like any other protein into amino acids. That's why they prefer injections, because they give direct and immediate effect of changing or reducing the excess glucose in your blood back to the norm. So that is what I can speak about insulin. Going back to our picture on your screen, we are moving to the next gland, and that is the adrenal gland. Looking at it, it is just located just above your kidneys. The adrenal gland has a major role in our body as it secretes a hormone we call adrenaline hormone. Hormone adrenaline secreted from your adrenal gland, particularly from the inner part of your adrenal gland. It's very important in preparing an organism for emergencies. Emergencies such as when you're frightened, when you're super excited, when you're in danger, anything. That is when this adrenal gland secretes the adrenaline hormone. Imagine you are walking, as I keep on saying, you're walking or wherever you're seated, as you look down, you find a very huge snake. When its mouth is open towards biting you, what would happen? Or imagine you're seated and then all of a sudden you hear a bomb blast near your home. Or say at night you're sleeping and thugs come in and then there are gunshots. So such things, like dangerous things that happen to your body. Sometimes we are in the car traveling and all of a sudden you witness an accident, hands-on, or maybe the driver, the car that you're in turns and rolls over and over again, and you're there. You cannot imagine what is happening. You all get so frightened, and maybe your life is saved, or maybe you see other people dying while you're looking on. So in case there is any danger, an emergency, or maybe you are frightened, or maybe you're anxious, and maybe when you're super excited. What are these conditions when you're super excited? Maybe when you don't expect to receive something, maybe your parent to give you something and they surprise you with it. And it's something that was the last resort in your mind that your parents can ever do for you. Or maybe when you've taken long to see a person that you love so much, and all of a sudden that person comes before you, you all get so excited. Or maybe when you get a glimpse at the person that you love so much emotionally, and you've taken long, or maybe you've had challenges and issues, and something happens, you get so excited. You've seen people like get excited. Maybe something happens that all of a sudden you don't expect, and then you become so emotional, you get tears of joy, or maybe you get something that overexcites you. All those conditions, frightened, excited, or maybe danger, the hormone that prepares you for such processes or conditions is adrenaline hormone. And because of that, what are its effects when it is released in your body? The effects are, when adrenaline hormone is released in your body, first of all, it will increase your heartbeat, the rate at which your heart is beating. At that point, it shows that the heart will pump more blood containing glucose and oxygen to give you enough energy to carry out the emergency activity that you're going to do, maybe to escape from danger, maybe to run away from a snake, maybe to run away from the gunshots, maybe anything that is happening. So your heart starts racing, beating very fast. It also increases your body's metabolic rate. That is the rate at which the metabolic reactions in your body take place, like digestion, respiration, excretion, and whatever. So the rate at which the body's chemical reactions take place increases once this hormone is released into your bloodstream. It increases your breathing rate. Oftentimes we've seen people who are scared, you're frightened, you start racing, are breathing very fast as if you are from running a 100 meters race. So the increase in breathing rate is all brought about by shedding of this adrenaline hormone in your blood. The other thing is it increases your blood pressure. The rate at which blood is being pumped, or blood flows faster than the normal rate. And as it's flowing faster, it is providing your different muscles and tissues enough oxygen and glucose that are going to be broken down, the glucose that is going to be broken down during aerobic respiration, to give you enough energy in order for you to fly or to fight or to run away from danger, or in order for you to respond to any emotional excitement that comes your way. Then it also increases the rate of conversion of glycogen back to glucose. Glycogen, as we said earlier on, is a storage form of glucose. When you have an excess glucose in your body, then we need to reduce it back to the norm by converting the excess glucose back to glycogen. And so when there's a lot, the adrenaline hormone is secreted into your blood, the glycogen is reconverted back to glucose in order for the glucose to be aerobically broken down to give you enough energy to help you run away from danger or escape danger. And then lastly, it causes contraction of the erector pili muscles, which hold the hairs over your skin. And that one results into the hairs over your skin to raise, and also for you to develop goosebumps. Oftentimes we've seen people who, when you're scared or you're frightened over something, you all of a sudden your body develops goosebumps. In Luganda we call it oyuwo lutiko tiko wenna wenna. When you're either too excited, or when you're too scared, or when you are exposed to something that is so pathetic, something that doesn't look good, and maybe say tsanyi or maybe a snake, something that is so pathetic, you all get goosebumps all over your body. There's a lot of adrenaline hormone that has been shed to your body. So all these activities that I've talked about result into you getting enough energy in your body, or production of more energy in your body. And at that point, the energy that is produced in your body makes you more energetic, that you're able to escape from danger. If not running away, if it's an insect or a bird, it's able to fly away from danger. Or if not, you're ready to fight back to the enemy. And because of that, this hormone is also known as the flight or fight hormone. Why the flight or fight hormone? Because it prepares you to fly away from the enemy, to run away from the enemy or from danger, or to fight the enemy. Sometimes some people have really, when they're angered, and they're angered so properly, they will start breathing at a faster rate. Their eyes will be, actually something that I skipped, this hormone that it does in your body, it also brings about dilation of the pupil of your eye. Chibango kanula amaso, in danger, and your eyes become wide open. So these people, some people when they are angered and they are so annoyed properly, they'll become racing, breathing very fast. They all become, the muscles will contract, and you see a misua all over their hands. And then the eyes pop out, or bakanula amaso, and they are ready to fight you or to fight the enemy because they are angered at that point. And all this is as a result of this hormone adrenaline that is shed in your blood. So this hormone adrenaline, what stimulates the adrenal gland to secrete this adrenaline hormone in your blood? I said 1, when you are in danger. 2, when you are excited. 3, when you're anxious. And sometimes when we get annoyed or get too emotional, this hormone will always be shed in our body. So that is adrenal gland and adrenaline hormone. The next gland, as you can see on our screen, apart from the adrenal gland, is the, I'll request the producer to put the picture on your screens. From the adrenal glands and the pancreas, we are moving down. The other glands that actually we always look at as reproductive organs. In females, we have the ovaries, and then in males, we have the testes. Now, these two are either reproductive organs when it comes to the reproductive system, but then in the endocrine system, they are also endocrine glands. Why? They are glands, or they are special organs that secrete hormones that bring about changes in the body of a man or a woman. And I will request the producer to relay the second drawing, the second picture, because this picture here is of a man, and someone may think, how can a man get ovaries? So we had to relay them. So here we're having both the female and the male, sorry. The first group of hormones, the pituitary, the pineal, the thyroid, parathyroid, the thymus, adrenal gland, the kidney, the pancreas, are all both in the females and in the males. But when it comes to the ovary and the testes, the ovaries are basically in the females, and the testes are basically in the males. Now, the ovaries as endocrine glands secrete 2 major hormones in females. So the 2 major hormones are we have hormone estrogen and then progesterone hormone. These are the 2 basic hormones that are secreted by the ovaries in females. And their major role, as we can see, in a female, estrogen hormone is very vital in controlling the secondary sexual characteristics in females. So it prepares a female towards onset for the secondary sexual characteristic. What are these secondary sexual characteristics that develop in females as a result of secretion of estrogen hormone? one thing I want to tell you is this estrogen hormone, much of it is secreted at puberty. When a girl reaches adolescence, that within your teenage age, from 13, okay, early 12. Some girls start at 9, all through up to around 19. There's this hormone is, estrogen hormone is at work. And what are these secondary sexual characteristics that this hormone brings about in females? The first of them being enlargement of breasts. When you look at that picture on the screen, both the males and the females have breasts. We all have breasts. But what is extra in females is, in females, the breasts become larger. Now, some students always give this point as a secondary sexual characteristic of females. They say development of breasts. That is very, very wrong. The right one is enlargement. Development is different from enlargement. We all are born with breasts, but they enlarge when it comes to puberty. So enlargement of breasts to different sizes depending on your genes or your family lineage. The next one is growth of pubic hair. That is in females. The pubic hairs grow under your armpits and around your reproductive organ. And then we have enlargement of hips, as you can see on that drawing, on the picture on your screen. The females always have larger or more hips than males. If you find a man with hips, there's a challenge, it's that man. Either that man produced a lot, has some female characteristic in him or whatever. So enlargement of hips. Then onset to menstruation. At birth, all of us females, we are born with our with eggs, but they are immature. They have only undergone the first phase of meiosis. They have not undergone the second phase of meiosis. And so we have them from birth, but they are very immature. But when we reach puberty, onset to puberty, and this hormone estrogen is produced in our body, then one egg matures at a time in a month. So when that month you get one egg maturing, then it will mature from the Graafian follicle by help of the follicle-stimulating hormone as well. It will mature into a mature ovum, which will be moved through your fallopian tube towards the uterus for implantation. But in any case, there is no implantation. Then that egg, together with the lining of the wall of your uterus, what you call the endometrial lining, it is shed out as monthly blood or discharge, which is not always a lot. Yeah, in some women can have one egg mature at a time in a month, but some women are so fertile that they could have 2 eggs from both ovaries mature at a time, and so some women will have menstruation at the beginning of the month and then at the end of the month. Those are women who are likely to become nalongos, or they're highly fertile. Then the other, that is menstruation. The other secondary sexual characteristic in females is enlargement of the reproductive organs. Believe me, you and me, the teenager who is seated looking at me, the senior 4 candidate, the senior 6 candidate, the size of the reproductive organs you had when you were still a baby, or maybe when you're still in P2, it's not the same size you're having right now. The size keeps on becoming larger, or becoming bigger. And in order to prepare you for your reproductive functions as a mature woman, that is, say, giving birth. So they keep on enlarging. Then females, their muscles soften. The muscles of the females soften and they become more smooth compared to the males. Then the other thing is you develop a soft and high-pitched voice. That is to the girls. A girl is supposed to have a soft and high-pitched voice. Though some girls can speak like men really, like with bigger voices, but there is a challenge. It shows that there is under-secretion or over-secretion of the estrogen hormone in your body. And then the last secondary sexual characteristic that we basically find in females as a result of this estrogen hormone secreted in your blood is getting attracted to the opposite sex. That is very normal. I keep on telling you young teenagers in class that if you be in class and you spot a boy or you spot a girl and you feel you're attracted to them, it's a very normal thing. It shows in future you're going to get married or you're going to get a person that you like most, and the two you can pair up and become dad and mom or husband and wife. And it can be controlled. So-called crush, it's not love. But getting attracted to a person of the opposite sex is a normal characteristic. And it shows that you are normal. You have shared estrogen hormone in your blood. So when that happens to you, say, wow, I have estrogen hormone in my blood and that I am attracted to this kind of a boy, but I can control this without even the boy getting to know that you're attracted to them. However, some of us, after getting attracted to any boy, we start throwing ourselves over and over again. That one is again being a little bit cheap. So those are some of the secondary sexual characteristics women develop as a result of shedding of hormone estrogen in their blood. So the second hormone is progesterone. This one is also secreted from the ovaries of females. And this hormone is very essential in pregnancy. One, it stimulates the growth or thickening of the walls of the uterus, what you call the uterine walls, in preparation for implantation. So what does this mean? It means that when you ovulate, when the egg comes out from your ovaries through your fallopian tube to the uterus, and that month you have ovulated, and it so happens that you copulate with when you're unprotected, or you have unprotected sex with a mature man. A mature man, I mean a man who is able to produce sperms. So when you excuse me. So when you ovulate and you're able to copulate or have sex with a man who is mature and the sex is unprotected, then the sperm that comes from the man will fertilize your egg. And upon the egg getting fertilized, fertilization of the egg can take place within your fallopian tube, and then the fertilized ovum, at that point it becomes a zygote. It moves through your fallopian tube by the help of the cilia, and then it moves to your uterine walls. And then with the help of this progesterone hormone, it will thicken the walls of your uterus so that the zygote will come and then sit on the walls of your uterus, what you call implantation. So it will get implanted on the walls of your uterus, and that is when that zygote cells keeps on multiplying, and then tissues form, and then a fetus is formed, and then by the end of the gestation period, that is the 9 months, you're having your baby out. So that is the role of progesterone. Very important one in preparing your uterine walls for implantation in order for you to get pregnant. It also maintains your pregnancy. In most cases, females who get who get miscarriages, like it's because of the fluctuations in the hormones. Sometimes you go to hospitals and the medical personnel, the gynecologist will tell you you have a hormonal imbalance. Hormonal imbalance in such a way that the amount of estrogen you're producing and the amount of progesterone you're producing, plus the follicle-stimulating hormone and the luteinizing hormone, which are our reproductive hormones, the ladies, are not balancing. Either one exceeds the other. And for these hormones that bring about reproduction in females, when one exceeds the other, it inhibits others. So for this case, secretion of progesterone in our blood to bring about implantation and maintaining pregnancy inhibits the hormones that bring about ovulation. So when there's enough progesterone in your blood, then the luteinizing hormone and the follicle-stimulating hormones are inhibited. So you cannot ovulate, or any other egg cannot mature at that point. That is why upon a woman getting pregnant, they cannot menstruate again, because at that point, within all that time, the ovulation is inhibited due to this hormone called progesterone that is being secreted in your blood, in your bloodstream. So it maintains pregnancy and then inhibits ovulation and until you give birth. And when you give birth, there's a hormone, another hormone that is secreted. I talked about it from the pituitary gland. We call prolactin, that brings about milk production. So also increase in the amount of prolactin hormone in your blood inhibits the ovulation hormones. That is why those times our great-grandparents used to use breastfeeding as a mode of family planning, because when you're breastfeeding, literally, as the baby is suckling, the prolactin hormone raises high in the blood. The hormones that bring about ovulation are inhibited, so you cannot ovulate overall that time you're breastfeeding. And so when you don't ovulate, it shows you do not have any ready egg to be fertilized. So during that period, however much you have unprotected sex, you can't get pregnant. However, it varies with an individual. To some females, they'll get pregnant, and immediately they give birth, then they will start ovulating. There is what you call hormonal imbalances. So it's not a stable family planning method to be used for all the different females around, but it can be used to prevent pregnancies in nature. So that is progesterone and estrogen in females. So, and the secondary sexual characteristics. Then we go to the males. I'd request the producer to put the picture again on the screen. To the males, they have what you call the testes. To some of us, we always confuse the testis with the scrotum and the so-called balls. No, the testis always enclosed in the scrotum, found dangling in between the legs of the males. I would request the producer to put that picture on screen. When you look at this picture, the ovaries are a bit higher above in the pelvic region. But then when you look at the testes, they are a pair in males. They are down, a little bit down in between the legs of a male. They are enclosed in a sac we call the scrotum, often devoid of hairs, or what you call pubic hairs. The major hormone these testes produce as endocrine glands is called testosterone hormone. In males, testosterone hormone is very important in bringing about the male's secondary sexual characteristics. So it controls the growth and development of the secondary sexual characteristics in males. And what are these secondary sexual characteristics in males? The first one being deepening of the voice. It's brought about by the testosterone hormone. And males naturally, when they reach puberty, their voices start changing. And how does the voice change? Most of yourselves, you see yourself like in senior 1, senior 2. As your voice is changing, you have a smaller voice and then a bigger voice coming. Smaller, bigger voice coming until the small voice is totally converted into a big voice. So deepening of your voice is very, very normal. It shows that you're a normal male who is secreting enough of the testosterone hormone. The next secondary sexual characteristic is growth of facial hairs, and particularly here we look at the beards. Oh God, men, upon secretion of this hormone in your blood, you will grow hairs, particularly the beards, and not only the hairs on your face, the hairs can also grow on your chest region. Those facial hairs or superficial hairs are normal. It shows that you are undergoing the secondary sexual characteristics, or you're turning from a boy into a man. The next thing in men is toughening of muscles. The men's muscle, they become really tough and they become more prominent, particularly on their hands or even their legs or whatever. You see they become more muscular in nature. So I would request the producer to put that picture on the screens. So when you look at these are teenagers, the girls and the boys. And so one of the common characteristics I said, why you're seeing them in pairs. The moment you reach puberty, you start getting attracted to the opposite sex. It's both in the males and in the girls. So it's one of the reasons as to why that shows that you are really a grown-up person. So you get attracted to a particular person with particular traits, oftentimes complementary to you. At your age, at puberty, 13, 14, 15, 16, 17, 18, 19, you only focus on the superficial things, the artificial. Man, dude has this, dude is tall, or dude has these superficial features or whatever this. So that is normal to both the boys and the girls. And then the boys look at the body structure of the woman, the hips, the so-called bums, and whatever it is. And then the other thing on men, which is a secondary sexual characteristic, is widening of the chest. Look at the chests of those two. Look at the chest of the guy in black and the chest of the ladies. The ladies' chests are a little bit more smaller, but the chests of the men broaden more. So at that age, you become, actually, your limbs, you become taller, and then your chest region widens, or it becomes broad. Though there are some boys whose chests are small, very small. There's a challenge there. Then enlargement of the reproductive organs to the boys, particularly the penile organ. I would say the boys who are seeing me, the size of the penis you had when you were still in P2 isn't the same size of the penis you're having at 15 or 16. It keeps on increasing in size, and there is a reason as to why it has to increase. Remember, also the reproductive organs of the girls also increased in size at puberty. So there is a reason as to why they increase in size, and it's very normal. Oftentimes I get some students come to me reporting, saying, why is it that the size of senior one particularly, the size of my penis is small and the other one has a bigger one? And I keep on telling you, with time also yours will grow big, and it's very, very normal. The next thing is growth of pubic hairs in males. Apart from males developing the beards and the hairs on the chests, they also get pubic hairs under the armpits and also around their reproductive organs, particularly on their V area. And then the males at puberty, due to secretion of the testosterone hormone, there is onset to what you call sperm production. They get stimulated to produce sperms, and there is onset to what you call wet dreams. Wet dreams, just like their name, wet dreams, it's a dream. You dream when you're in that donkey and you are admiring that girl that you like most, and you're touching, you are fibbling around their body, and by the time you're about to do the actual action, the bell rings, and then they wake you up, and to find yourself that you are having, you pour out sperms in the night. So that is wet. It's a dream that is wet, and it is normal to every adolescent. Then lastly is, as I said earlier on, attraction to the opposite sex. That is also both to the boys and to the girls. When you reach puberty and the girls secrete estrogen and the boys secrete testosterone hormone, you're bound to get attracted to each other. But this attraction can always be controlled as a person, and it is normal when you get attracted to a girl because of whatever you're seeing on her body. Just know you're a normal man, and in future you're bound to have to get married, to get a wife, or to and become a husband. And by the way, to the boys, whenever you get all the characteristics I've mentioned about, it's very normal. It shows that you're going to turn into a very responsible man who will later on get a wife. But now, what are the challenges? In any case, you under-secrete any of the above hormones. Or if you under-secrete testosterone hormone as a man, then some of the things will not be produced. And like You've seen men who grow from their puberty, the man turns 35, the man goes to 40, and no beards. Hello? No beards at all. So the under-secretion of any of these hormones, certain secondary sexual characteristics will not be manifested very well. You've seen men whose voices are like those of ladies. Very small, soft, or like of a young child. Or maybe you've seen men with very, very small and tiny chests, or men who behave like women. They always move with their hands like this, always moving like in catwalk, modeling. So the moment you have under-secretion of any, or you have the female hormone in you manifest more than the male hormone in you, then you're going to get more of the female characteristics will come out outstanding in you than the male. Likewise, in the females, you've seen females who develop beards. Oh, you've seen females, girls who are having very deeper voices. Or you've seen girls who have grown more like males in the way they do their things. Everything, and they can call themselves tomboys. Like they love jeans, they love this, and they're not girly at all. Everything, they are harsh, very rude. They have muscles. They have thicker voices and whatever. Such, in any case, the male hormone manifests more in you than the female hormone, then you're bound to showing more of the secondary sexual characteristics of the opposite sex in you. And at that point, it's really quite absurd, but it's really so abnormal. So those are the glands I wanted to talk about today. And maybe to clarify something small, in a particular in-app question, they would draw for you a command. And then they'll put glands here, and then they'll put other glands here. And then they'll ask you to label. This is typical in the 1996 UNEP question that I have left behind. They'll ask you to label these and these. So because they have not differentiated whether this is a man or a girl, some of you will label these ones under the legs as ovaries and these ones as testes. You have to know that the testes are found more below the pelvic region, within the limbs, and the the ovaries are within the pelvic region. So with that, I come to the end of today's lesson. Thank you so much for giving me an audience and listening to me and studying biology with me. The next time I come, we are going to look at the nervous system. So as now today we have ended the endocrine system, the hormonal system, as part of coordination in animals, we shall start on the nervous system, comprised of the brain, the spinal cord, the sense organs, the reflex action, the nerves, and whatever. It will be so exciting and interesting. Hope you stay tuned in. As I conclude, the references for today are UNEB 2013, question number 32, paper 1, and then UNEB 1996, question number 32, paper 1. I have used Jeff Howard, Macmillan Secondary Biology, International Edition. I remain Jovia Katuhaise, your biology teacher for God and my country.
Bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'ey'e Kabalagala toba bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga, nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe